All right, what up, people? Okay, today we're going to talk about 3.6, which is lines in a coordinate plane. We're going to talk about how to graph lines, write their equations in slope-intercept and point-slope form. We're also going to classify lines as parallel, intersecting, or coinciding. Okay, real quick, this is all review. Okay, slope-intercept form and point-slope form, which we're going to go into here in a second. And we also have parallel lines, we just talked about, intersecting, or coinciding. Okay, we kind of got rid of the perpendicular there. So we'll talk about this in 1 second. So the first equation set that we have is point slope, which is in fact what it means, point and a slope. You should remember it's something like y minus y1 equals m times x minus x1, where x1 and y1 are just points that you plug in and m is your slope. The other one, which is slope-intercept, you've already seen before as well, which is y equals mx plus b, where b is the y-intercept and m is the slope. All right, so given the example that I want to look at, I want to write an equation of a line in the given form. So right now I want to write the equation of a line with a slope of 6, which is m, through 3, negative 4 in point-slope form. Well, the point-slope formula is y minus y1 equals m times x minus x1, which is really simple to understand because you have a point and you have a slope. So all you're going to do is you're just going to plug your points in. Okay? So your point is x1 and y1. And so we just plug those points into the locations of where we have. The minus is always there. And so if you notice, we have a minus and a minus right here, which is going to make y plus 4 equals 6 times x minus 3. Okay? And we stop there. We're not going to solve for y. Okay? We're not going to solve for that because we just want point-slope form. If we wanted slope-intercept, then we could solve for y. Okay, so now what we're going to do is we're going to find the equation of a line in slope-intercept form. If you recall, slope-intercept form is y equals mx plus b. Okay? Now, what we have to ask ourselves is, in this given information, do I have anything that I can use to plug into this equation? And the answer is no. I don't know the slope and I don't know the y-intercept. So what I have to do is I have to find the slope to begin with. And we're going to do that by using the formula y2 minus y1 over x2 minus x1. So I'm going to do 2 minus 0 over 1 minus negative 1. And that's going to give me 2 over 2, which is equal to 1. Now I know my slope, which is m, so I can plug that in there. So let's go ahead and do that. Y equals 1x plus b. All right, now the last thing I have to do is really just take one of these points and plug that in so that I can find b. Now look, it doesn't matter which one you use, you just pick one. So I'm just going to take this first one, which is x and a y, okay? So I'm just going to take that y and I'm going to plug it in where I see y. And I'm going to take that x and I'm going to plug it in where I see x. And what I'm going to do is I'm going to solve for b. So I have negative 1 and 0 on this side plus b, because 1 times negative 1 is negative 1. So we're going to add 1 to both sides, and I'm going to get 1 is equal to b. Now the cool thing about this is now I'm done. The only thing I have to do is plug everything in, keeping my x and y intact. So y equals 1x plus 1. And that's it. Make sure you don't plug the point in. You got to keep y and x in the equation. All right, so now we're going to try another problem just like this, where I have the y-intercept is negative 5 and the x-intercept is 3, and we want to put it in point slope. If you remember, point slope is y minus y1 equals m times x minus x1. What we have to have is we have to have a point and we have to have the slope. Now, if you remember, okay, we have a couple points here, okay? X-intercept means that's where it crosses the x-axis. It says it's crossing it at 3. So that means that my point is 3, 0, okay? Because it's over 3 and up 0. And if my y-intercept is negative 5, then that means that my point that's there is going to be 0, negative 5. Well, it doesn't matter which point I pick to plug into this, so I'm just going to pick this one that's not negative. Okay, so y minus 0 equals m times x minus 3. Okay, so the idea now is that we have to find the slope. Now, if you recall from the last section, we can just count that slope, or we can use this point and this point to create the slope the slope formula. It's up to you, whichever way you want to do it. But for me, I'm just going to count it. I'm going to count up 1, 2, 3, 4, 5, and over 1, 2, 3. So what's going to be is going to be y minus 0 equals, my slope is up 5 and over 3. So 5 over 3 times x minus 3. And that ends the problem. All right, now we're going to talk about graphing, okay? I just want to talk real briefly about this. It's easy to graph things when they're in slope-intercept form. Because if you remember, this is where you start, and this is where you go from. So for example, if I graph this, it starts at 1, because it's in slope-intercept form, and that has to be my y-intercept. And then the slope tells me that it's going to go up 1 and to the right 2. So the way I always do it is I say, okay, this tells me to go up, and this tells me to go right. So I'm going to go up 1 and to the right 2. And I only need 2 points to make a line. When you were in algebra, the teacher may have said, okay, I need to see 3 points. I need you to go 2 different directions. I need whatever. It doesn't matter, okay? The reason why that is because you know that 2 points determine a line. Okay, that's a postulate. So in geometry, we only need 2 points to show this. So you need to be able to graph those. Okay? Okay, now we're going to graph a line that's in point slope form. You can do this one of 2 ways. The first way that you can do this is you could solve this for y, and so that it's in y equals mx plus b form. Okay? It's kind of up to you. For me, I'm just going to use the other way, which is I know the slope is -2, and I know a point. Okay, so the point is going to be -4 because it has to be the opposite of this, and +3. And my slope is -2 because the reason why it's -4, just so you know, is because the formula is y minus y1 equals m times x minus x1. Okay, and since this negative is right here and it made this positive, we know this has to be -4. And since this one's still minus here, we know it has to be +3. Okay? And remember, y's go beside the y and x's go beside the x's. So now I have that point. If you don't like this way, then you're more than welcome to solve for y. But now since I have a point and a slope, what I can do is I can go ahead and graph this. So let's go ahead and graph this point, which is going to be over -4 and up 3. There's my point. And then I'm going to use, now since I plotted this point, now I can use the slope that is -2. We can put this over a 1. This tells me I have to go down from that point 2 and go to the right 1. So down 2 to the right 1. Remember, we only need 2 points. And make sure you extend your graph all the way out. All right, so this one I wanted to talk about because this is the one that most kids usually mess up. Okay, this one doesn't have an x. Okay, so since it doesn't have an x, it means there's no slope, which means that that line is horizontal. Okay, which means that that line enters the graph at -3. Okay, that's how you graph it. Now, the other way to look at it is if I have something like x equals 4. It has no y, so it cannot cross the y-axis. That's what I always think about. So there's your x equals 4. So those graphs are horizontal and vertical, and you need to make sure you understand how to graph those. All right, the last thing I want to talk about is the difference between different lines. We have parallel, we have intersecting, and we have coinciding. All right, these are new terms, some of them, not all of them. Parallel, you know, means it has to have the same slope. Okay? Example, y equals 2x plus 4, y equals 2x minus 2. Notice they have different y-intercepts, but they have the same slope. Okay? So same slope, that would mean they're parallel. intersecting, not same slope, or y-intercept. I mean, it could have it, but it doesn't have to, okay? But basically not the same slope. That means they're going to intersect, okay? Coinciding means same line. And what it means is that I have two lines that are laying on top of each other. So if I have a graph and I take a look at this, it's like if I drew a line like that and then I took another line and laid it right on top of it, okay? That means they have to have the same y-intercept and they have to have the same slope. So something like y equals 2x plus 2 and y equals 2x plus 2. Those are coinciding lines because they're the same line, okay? Now, going back to these intersecting lines, I said it doesn't have to have the y-intercept being the same. It can have the y-intercept the same, but it can never have the same slope. All right, so what I want to do is I want to determine whether or not these lines are parallel, intersecting, or coinciding. You could graph them if you want to. Some people like to look at it visually, but when I look at it, I just go ahead and say, oh, well, my slopes are different, my y-intercepts are different, although it doesn't matter, so these have to be intersecting. Okay, that's how I look at this. Let's determine whether or not these lines are parallel, intersecting, or coinciding. Okay, if you notice, this one, y is already by itself, but this one, y is not by itself. So I have to make it by itself because that's the only way that I can look at the slope and the y-intercept of it. Okay, so right now we have a slope of -1/3. Okay, and we have a y-intercept of 5. Over here, if I divide by 6 to get y by itself, I'll have y equals, this reduces to -1/3, and this reduces to 2. Now, they're not the same line, right, because they have different y-intercepts, but they are parallel because they have the same slope. So you would say parallel. And guys, this is how we prove and show that these are parallel, by showing that the slopes are the same and that the y-intercepts are not. Okay, let's look at this one. If you take a look, both of these equations are not solved for y. So what I want to do is I want to solve them for y. So right now, to solve this one here for y, I need to add 4x to both sides. Remember, this doesn't make 20x over here because they're not like terms. You have 2y equals 4x plus 16. You might say, why, Hostetler, why you put the 4x in front? Well, it's because I like to have the slope in the front and not afterwards. So we're then going to divide by 2, and that means y is going to equal 2x plus 8. Now I have it solved for, okay? I want to go ahead and do that over here. So the first thing I need to do is distribute the 2. So I'll have y minus 10 equals 2x minus 2. Last step, add 10 to both sides. Remember, when you're not adding it to the 2x, you're adding it to the -2. And so you'll have y equals 2x plus 8. If you look, they have the same slope and they have the same y-intercept, so they have to be coinciding. All right, guys, last problem of the day. Woohoo! Let's go. What we're going to do is we're going to take 3x plus 5y equals 2. We're going to take 3x plus 6 equals -5y. And what we're going to do is we're going to solve each of these for y. So for this one, we're going to subtract 3x because we're trying to get y by itself. So bring that 5y down. That's going to be equal to -3x plus 2. We divide everything by 5. Now we have y equals -3 over 5 times x plus 2 over 5. It doesn't really matter what this is. We're just kind of looking at them to see whether or not they're parallel, intersecting, or coinciding. All right, over here, if you look, I can flip this around, okay? So I can flip this around so that the y is on the left and that the other stuff is on the right. And now all I have to do is divide by -5. Okay? So when I do this, I get y is equal to -3 over 5. Since the negative's on the bottom here, it doesn't make a difference. This whole thing is negative then. Now, if both of them, the top and the bottom, are negative, it would make it positive. okay? But I still have that x, and then I have minus, because of this negative on the bottom, 6 over 5. Notice that the 6 over 5 does not reduce, and 2 over 5 and 6 over 5 are not the same, but the slopes are the same. So this sometimes throws people off because of this negative here on the bottom, but it doesn't matter. The whole thing is negative. Okay, if one of them is negative, then the whole thing's negative. If both of them are negative, then it's positive. And that's because you have a negative over a negative, which makes it positive. So since these slopes are the same, they're parallel. And so this is how you're going to have to do the problems in the homework, okay? So make sure you take a look at that. Okay, so it's wrap-up time. So we have two different ways that we write equations. We write them in slope-intercept form, and we write them in point-slope form. So we got y equals mx plus b, and we have y minus y1 equals m times x minus x1. So those are your two forms. To graph, I normally would probably try to switch my stuff into slope-intercept form. Start at the y-intercept, count out your slope. Make sure you have at least 2 points, because 2 points determine a line. And then we have the three ways to determine what type of lines they are. They're either going to be parallel, they're either going to be intersecting, or they're going to be coinciding. Parallel, same slope. Coinciding, same line. Intersecting means that everything's different, okay? And they eventually are going to intersect somewhere. All right, y'all. Have a good night.